Question number 2, we've done this question before in degrees in the last section. Now we're doing it in radians. We have some like terms. So again, initially the question here often causes trouble for students because they forget, hey, I can combine like terms. My goal is if I get cos x by itself, maybe I can solve. So to start with, I am going to move all my numbers to the left. So I'll move the 4 over to get minus 2, and I'll move my cos x. So I just put my like terms together, and I get negative 2 equals 3 cos x. From here, it's really easy to divide both sides by 3, and we get cos x by itself. Now 2/3 is not on your unit circle, so we're going to have to go to our calculator here. And on our calculator, when we find our reference angle, so our reference angle for x, remember for reference angles are always positive angles between 0 and 90 degrees or between 0 and pi over 2 radians. So when we find a reference angle, we always need to make sure we put in positive values. So I'm going to go cos inverse, cos inverse of positive 2 divided by 3, and this will be my reference angle of 0.841. And like I said before, sometimes I just put the 3 dots there to remind myself, don't round early, keep all of your decimal places to the end. So then I go to solve, and cos is negative in quadrants 3 and quadrants 2, quadrant 2 and quadrant 3. So I'm going to go back to my calculator, and I'm actually going to store this answer as x, so I can use it. So in quadrant 2, it would be pi minus my reference angle, and I made x my reference angle. So I get 2.3, and we'll check what does it want us to round to the nearest hundredth. So that would be 2.30. And in quadrant 3, it would be pi plus my reference angle, 3.98. And I'm going to make a little note. This is not a bad habit, even though this is not the final answer and this is not necessary. Well, it might be, we'll check. But we're going to first sort of get into a habit of finding our solutions if we went around the unit circle once in the positive direction. And maybe we also want to make a note here, this one was quadrant 2, this one was quadrant 3, because sometimes in radians it's a little bit harder to see the numbers where they are. But now I'm going to go back to my question and check where were they looking. Okay? The domain is from negative pi over 2 to 3 pi over 2. When I get a domain like that, I still think about my unit circle and I think about standard angles. They always start at 0. So if I'm going to 3 pi over 2, that means I'm thinking of positive angles in quadrants 1, 2, and 3. And if I have that negative pi over 2, I also think about having negative angles from 0 to negative pi over 2. So if I have a domain that has some negative and some positive, I always sort of break it up at 0 because angles in standard position start at 0. Are my 2 positive answers in quadrant 2 and 3 still fine? They are. So all of that extra thinking and we didn't even have to worry about it. And then it says also to write the general solution, and remember that our general solution is just writing coterminal angle so to write my general solution, I would go x equals, I I have those two answers, 2.30 and 3.98. I'm in radians, so I go plus 2k pi plus 2k pi. That gives us all the coterminal angles as long as k is an integer.
How did you get the 327?
So cos x and 4 cos x are like terms, and I just brought this one to that side and combined those like terms. Yep, not a problem. Those are good. Like, anytime you see something that's sort of like, that's just a little bit confusing how I get that, ask that question. Because sometimes after you see it, exactly, you're like, oh, that makes total sense, that's really simple, but that's okay. All right, part B says, to the nearest degree, solve the equation root 2 cosecant x equals -5. I'm going to just put this on a new page for us. Again, I have a trig function right here. First of all, if you're solving a trig equation, you would like to get that by itself. I can do that easily by dividing both sides by the root 2. Now, if you know that cosecant of x is root 2 over -5, we can always change our reciprocal functions to ones that we're more familiar with. So I can change this to sine. Why is that nice? Because we can use our calculator. Obviously, -2 over root 5 isn't on our unit circle. So we find our reference angle by going through our calculator. Once again, reference angles are always positive, so I'll go sine inverse of +2 divided by the square root of 5. And I get a reference angle of 1.07. 1.107. And sine is negative, so we know that our answers are going to be in quadrants 3 and quadrants 4. So again, I'll go to my calculator. I'm going to save my reference angle as x. And in quadrant 3, it would be pi plus x. And in quadrant 4, it would be 2 pi minus my reference angle. So I get 4.248. What does it ask us to round to? To the nearest, degree. This is going to happen to you sometimes as well. You're going to be in the mode. And notice how I was like, I'm just in the mode, I'm just solving. And now I realize things are in degrees. So I'm going to have to go back to my calculator, go to my mode button, change it to degrees, refigure out my reference angle. So now when I type this in and enter it, I get an answer in degrees. 63.43. degrees. I can take that answer and store it as x. And then in degrees, in quadrant 3, it would be 180 plus my reference angle. And it says round to the nearest degree. Yes.
For the square root, why is it like the square root just being the bottom?
Oh, that is because it's not. Must be Monday morning. You're right. For the square root, when I flipped it, it doesn't change. We're going to like redo this question. This will be the greatest video of all time. So we're going to put the square root of 2 on the top and the -5 on the bottom, because we're going to flip them, which, once again, changes my reference angle. So now I'm going to go sine inverse and make sure I type it right. Negative square root of 2, all divided by 5. And my reference angle, and I put a negative 2. Sine inverse of root 2. Reference angles are always positive. I did that, yeah, on purpose, sure. There, 16.43. And then this question said, round to the nearest degree. So you should have this, store this as x. You should have this sort of checking back with the question quite a few times, because you will notice that you're making mistakes, okay? So now I can take this answer, and in quadrant 3, 180 plus x, 196 degrees, and it did say to the nearest degree. So I'm going to write 196 degrees, and in quadrant 4, that would be 360 degrees minus my reference angle, 344 degrees. Of course, this was quadrant 3, this was quadrant 4, and now I'm going to look at my domain, and it has positives and negatives. So for positives, it's only looking from 0 to 180. In negatives, it's looking from 0 to negative 180. Are my answers in the domain? No. So I would have to say, temporarily, let me just put a line through these. I'm going to say the actual answers, this one, will be 100 and negative 100 and add up to 360. Negative 164 degrees. And this one will just be negative my reference angle. Of course, if your reference angle is 16 degrees, this one here, in quadrant 3, you can think of just doing 180 minus your reference angle to get the 164, and think I'm going in the negative direction, that it needs to be negative 164. For the general solution, we take our two answers. I like to use the positive ones, 196 and 344. The textbook might use the negative ones because they gave us those answers.
So like on a test, we could use the first two values even if it doesn't like fit in the domain?
Yeah, for the general solution, yes. Because the general solution, what this means in the red box, that's all the coterminal angles with 196 degrees. And negative 164 is coterminal with 196. So if I started with the negative 164 and did all the coterminal angles with negative 164, it would include 196. So when we're writing all coterminal angles, which is something that's going to be on your chapter 6 test, it doesn't matter which angle you start with. When you add the 360 degrees times k, it hits every single one that's coterminal. I always like to start with the first time around because I find that those numbers are something you're more familiar with. Okay, questions to circle on this one are 6 and 7.